Hi everyone and welcome back to my channel. So we are in the 18th video in this series that I have started on social information networks. We've been discussing all the important concepts that are there in this course. So social information networks is an important course in the field of computer science, and if you haven't checked out the rest of the videos in this course or in this series, do check it out. I've given the link to the playlist in the description. So in this video we are going to discuss hierarchical clustering. And more importantly, or to be more specific, in this video we will be discussing agglomerative clustering, agglomerative hierarchical clustering in detail. And there's another kind of hierarchical clustering called divisive hierarchical clustering. So we will be discussing divisive hierarchical clustering in the next video. So now, firstly, what is clustering? Clustering is basically when you have a set of nodes, we want to separate out the nodes which are much closer to each other compared to others. So visually, if we see, these nodes are closer to each other than these nodes, right? So we want to separate out, and in this case forming two clusters. So this is what clustering is all about. Now, what is agglomerative, or what is hierarchical clustering? Hierarchical clustering means that we are trying to separate out these clusters, or we're trying to create these clusters in different iterations. That is, or beginning with something, we are going to move forward, and finally at the last step of our process, we will have the clusters that are there. It's a hierarchical approach. That is, one after the other we are doing, and finally in the last step we will have the required number of clusters. Our nodes will be in the required number of clusters. Now, what is agglomerative clustering? In agglomerative clustering, what we do is we have a set of nodes. In the first step, or initially while starting, we consider each node to be a separate cluster. Okay, and then as we move forward, we choose the closest node to one of the clusters, and then if they are close enough, we move them to whichever two nodes are the closest to each other amongst all of the nodes that we have. Those two will become one cluster, and we will make them one cluster, and the rest of the clusters will remain the same. So eventually, as we move forward, as we finish the iterations, we will understand which all nodes are together and which all nodes are not together. That is, we'll understand which are the clusters that are there in our system, or in our set of clusters that we have. What is a divisive approach? In divisive approach is basically the opposite to agglomerative approach. Agglomerative approach is that we are deciding that each of them is one separate cluster, and we are trying to form the clusters. That is, merge the clusters to get bigger clusters. Right. So what does that mean? That is like we are going from the bottom to up approach. Right. Now, what is divisive hierarchical clustering? It is the opposite to agglomerative clustering, in which we consider, if we have 5 nodes, we consider all of them to be one single cluster, and we try to break it into separate clusters so that we get the required number of clusters. Okay, so this is what divisive hierarchical clustering does. So this is a top to bottom approach, or bottom down approach. Okay, so now in this video, we will be discussing agglomerative clustering in detail. We will also be solving a numerical for this. Okay, so there a set of points. I'm going to give the points here. Point number 1 is 0.4 comma. So this is how you give points, right? You have the x coordinate and you have the y coordinate. This is how you represent points in mathematically, right? So point 2 is 0.22, 0.38. Point 3 is 0.35, 0.32. Point 4 is 0.26, 0.19. Point 5 is okay. Point 5 is 0.08, 0.41. 0.6 is 0.45, 0.3. Okay, now this is the set of, these are the set of points that we have which we want to break into clusters based on the distance. Now again, there are a lot of ways in which we can calculate the distance between 2 points. One such method is Euclidean distance, right? So if we have 2 points xy and AB, the formula for the Euclidean distance between them is root over of x minus a square plus y minus b square. Okay. So this is the formula for Euclidean distance. This is one way of calculating distance between 2 points. We have another method called, which is basically the dot product, which is nothing but xa plus yb. This is a simpler method of calculating the distance. So you have many more similarity or distance measures, which, like for example, you can use, like these are the distance measures, right? You can also use similarity measures. You have the similarity measures like cosine similarity and so on. We've already discussed. So now moving on, in this video, we will be using the Euclidean distance to calculate the distance between 2 points. Now, again, there is another thing that we need to note here. There are three ways in which we will be using this distance. The first one would be, okay, I'll just start doing the numerical and then we will discuss those three methods. Okay, so the first step is to calculate the distance between all the points that are there in our matrix, or in our graph, or all the points that we've been given to perform agglomerative clustering on. So we need to generate a matrix for that, P1, P2, or basically a table, P3, P4, P5, and P6. Similarly, P1, P2, P3, P4, P5, and P6. The diagonals will be filled with 0 because the distance from the one point to the same point is 0, right? So P1, P2, P1, P1, P2, P2, P3, P3, P4, P4, P5, P5, P4, P4, P5, P5, and P6, P6 will be 0. Okay. Now, how do you calculate the Euclidean distance between 2 points? If you have, for example, you have to calculate for P1. Okay, we'll not fill the top half because it will be the same as the bottom half. If we want to calculate the Euclidean distance between the first 2 points, how would we do that? We want the distance between P1 and P2 first. So what is the formula for Euclidean distance that we've discussed? X minus a square plus x minus b whole square under root of that, right? So now P1, P2, if we follow this, that would be 0.4 minus 0.22 whole square plus 0.53 minus 0.38 whole square under root, which is basically equal to 0.18 whole square plus 0.15 whole square under root. 0.18 square will be what? 0.0324, and 0.15 square will be 0.0225. Now under root of this will be equal to 0.0549, which is basically equal to 0.23 under root. So I've used the calculator to calculate the root, so you can do that too. Now we will fill this 0.23 here in distance in the column of P1, P2. Similarly, if we fill in the entire table, I already have the distances, so I'm just filling it here. If we fill in all the distances, 0.2, 0.15, 0.34, 0.14, 0.28, and 0.29, 0.23, 0.25, 0.11, 0.22, and 0.39. Now, when we have the data like this, now, how will we know which 2 points are the closest to, which 2 points are the closest 2 points, so that we can merge them to form a cluster? So out of all these, which is the smallest number? 0. Oh, I'm sorry. So which is the smallest number? 0.11 is the smallest number. So we are going to merge node number P3 and node number P6. Right. So we'll be making the diagram here. So node 3 and node 6 are together. Now, moving on, let us now reconstruct the table. So we need to reconstruct the table in each step. Okay. But, okay, first let us reconstruct the table. So P1, P2, now P2, now P3 and P6 are together, so we write them down together. Then we have P4 and we have P5, right? Similarly, P1, P2, P3, P6, P4 and P5, right? So 0, 0, 0, 0, 0, and P1, P2, these distances remain the same, right? 0.23, 0. Okay, so now when you have the nodes like this, P2 and P3, P6, how are you finding that? How are you going to find the distance between these two nodes, right? So what we are going to do here is, this is what I was talking about before. We have three methods to decide what we are going to fill in the table here when we have between a node and between a cluster. So the first method is known as single linkage method. So when you have single linkage method, you choose the smaller distance between the both. Like for example, you have to calculate between P2 and P3, P6, right? So what we are going to do here is, we are going to write the smaller number, that is P2, P3. P2, P3 is what? 0.15, and P2, P6 is what? 0.25. So we write the smaller out of both of these, right? So we take the smaller number out of both of these. This is called single linkage method. Now we have something called complete linkage method. In this complete linkage method, what we do is, we choose the larger of the two numbers, that is 0.15 and 0.25. We choose the larger, which is 0.25. Right. Now, moving on, we have a third method called average linkage method. So in average linkage method, we take the average of both the distances that we have. That is, we take the average between 0.15 and 0.25, which will be 0.15 plus 0.25, which is 0.4 divided by 2, which is 0.2. So we'll take 0.2 in that case. But let us say we are following the single linkage method. Okay. So in the single linkage method, we will be choosing 0.15 because they are smaller out of 0.15 and 0.25. So like this, we will be filling the data, right? So this 0.2 between P2 and P3 is what? 0.15. And between P1 and P3, P6, P1 and P3, P1 and P6, it will be 0.22. Now, similarly, we fill in the entire table: 0.37, 0.2, 0.34, 0.14, 0.28, and 0.29. Now, which is the lowest in all of this? That would be 0.14. So, which means that P5 is going to go in with P2. Right. So node number 2, node number 5 are also together. These two form a cluster. Right. Now the next step is to again redraw the table. So we have P1, P2, P5, right? P3, P6, P4, similarly here P1, P2, P5, okay, P3, P6 and P4. Now the distances, like just like we did before, we'll fill in the distances. This is 0.23, the lower one. This is 0.22, the lower one. This is 0.15, the lower one. This is 0.37. This is 0.2. And this is 0.15, all lower ones. Now, which is the smallest amongst these? Again, here we have two options, right? That's another problem. So you can choose any one. So I am going to choose this one, right? What this means is P3, P6, P4, sorry, P3, P6, P2, P5, these two clusters are together, right? Now we join both of these. Now, moving on to the next step again, we redraw the table once again, forming P1, P2, P3, P5, P6 and P4, P1, P2, P3, P5, P6 and P4. That's again 0, 0, 0, 0.22, 0.37 and 0.15. Now, which is the lowest amongst these? We have 0.15 as the lowest. So we connect P4 with the bigger cluster. So it's going to be like this. Okay. Now we draw the table one last time, which is P1, P2, P5, P3, P6 and P4. And we have P1, P2, P5, P3, P6, P4 and 0, 0. And the distance between this is 0.22 because that is the lowest again amongst this and this. Okay. 0.22 and P1 is connecting to these. So what we're going to do is 1 and we're going to connect it like this. So this is your final cluster or this is the overall or the final way in which your clustering looks like. So if you plot it on a map or if you, on a graph, so it will be 5, 2, these two are together, then you have 4, then you have 3 and 6 which are already together, then you have these two which are in one cluster, and then you have your P6 which is with this, and then you get your P4, right? So this is basically how your clustering will look like. And then after this you also have your 1. So this is how your clustering will look like in the order that we got the values. So the final graph or the final connected clusters that we got 3, 6, 2, 5, 4 and 1. This thing is basically called a dendrogram. Okay, this is called a dendrogram. And this is used when you want to do hierarchical clustering. Okay, now in your exam they might be asking you to perform agglomerative clustering using single linkage, or perform agglomerative clustering using complete linkage, or perform agglomerative clustering using average linkage. When they give you single linkage, you will choose the smaller out of the two. If they ask you to do complete linkage, you will have to choose the larger out of the two. And if they ask you to do average linkage, you will have to take the average of both the distances. That is how you fill in the next table or the table on the next level. Okay, so this is how you do agglomerative clustering. I've discussed the 3 ways. I hope you got to learn stuff from this video, and if you did, please do like, share and subscribe, and thank you guys for watching.